Hey guys, so I got a short video here. I'll try to keep it short anyway. Just want to do a quick demo of these ringer circuits and how you can pulse them with one of these driver circuits. So I've shown this one in one of my previous videos. So I'm gonna I'll give a demo here quickly with just the ringer circuit hooked to the battery, powering the light bulb, and then I'm gonna disconnect that and hook up the driver circuit that I have right here. It's same as all my other driver circuits you can see in my videos, and there's even a how to build this if you look back. And the back EMF is going to go into this nickel metal hydride battery here. This is the voltage of it, 9.53. So that's where the flyback is going to be going into here once it's hooked up with the driver circuit. And then this is the input once I hook it up to the battery. And sorry about that noise in the background. This place is run off solar panels and wind turbines, so it's hard to get everything quiet in here. There's always seems to be a fan going. I've been trying to get the noise level down for the videos, but it's pretty hard. But as I was saying, anyways, the power going into the circuit is going to be right here. These two leads is what's going to be going in. And that's just going to be the positive, negative going in. And the back EMF coming off of pounding that coil with the frequency is going to be collected in here. And this is going to be the input from the battery going into the driver circuit once I hook it up. But for now, I'm just going to show a demo of the light running just off the ringer circuit without the driver circuit. I already have the negative hooked up. It's right from here to there. And here's the positive. It's 26 volts going in. Here's the meter. And all I have to do is come down here to the gauge, connect it. Get it to start. That'd be easier up here. There. So there it is. We're at just under 150 milliamps. And it should say the same on this gauge. Yeah. These gauges are really accurate. So you can see the light's pretty bright. It's pulling about almost 4 watts. So now let's just see, and I also have the scope hooked up here. Once the scope is going to be hooked up where I normally hook it up with my motor coils. Positive is the yellow, black is the negative. That's going to be the input to the ringer circuit coming from the driver circuit. That's where it's hooked. Should be able to see the back EMF from there. And then the voltage is right here for the back EMF. Battery bank, which is right here. Which is right there. Just put you like that until I can hook it up. Oops. Just trying to do this quickly. Try that. Okay, now I'm going to get rid of these wires completely. Or that one I can leave there. No matter. This one gone. This one gone. Put this is the output from the driver circuit going into the ringer circuit. And this is the positive coming out of the driver's circuit, going into the ringer circuit. Here's my negative going to the battery. And here's the positive going into the driver's circuit. So I'm going to start with it on low. So it'll be just pulsing at a low duty cycle. So it's running now. Let's see, here's the current right here. And you probably already see the back EMF going up. Battery voltage. So it's collecting back EMF off of the ringer circuit. That's what it's doing. And it's pulling 48 milliamps. And there's a shot at a scope. And you see here. $48. No. Start bringing it up. See, there's quite a bit of back EMF coming off of it. Just over a watt going in right now. So now I've brought it up to 60 milliamps. Back EMF got a little better. Or flyback. I don't know what there is for wireless. There's nothing. Got some over here. Doesn't cause any extra input on the battery. Now let's turn this up. So I'm just over 2 watts now going in. 2.15. Got more back EMF. Bring it up to about 3. It's 3.19. 3.27. Getting some wireless power over here. Right on the battery terminal here to get wireless. Doesn't change the input at all. Let's turn it up some more. Oh, wrong one. So we're at 3.35. 125 milliamps. Still have the back EMF. Light's getting pretty bright. So turn it up some more. And like this gauge is measuring what's going into the circuit, and this one is what's measuring what's coming out going into the ringer circuit, and they're identical readings. But I don't have anything measuring the back EMF, which is showing here with the voltage going up. But what I do have is something to notice is that the voltage that is coming, that is seen right here, is only like 8 volts. As you can see on the scope right here. It's this bottom spike right here that is, you know, for some reason it cancels out the input. Like it pulls it down really far, but it uses the back spike, like the ringing of the circuit. What makes it so efficient. And you can see like the bottom voltage is let me pause this and do it furthest down here. It's 37 volts. And the input is only 26.6. See, this is the back spike from the driver circuit, and this is the back spike from the ringer itself. So it makes it kind of interesting like that, how the power is getting moved around. So I'll turn it up some more. I should be able to get it full blast, no more pulsing, and the back EMF will go away because it's not being pulsed anymore. And that's it right there. It's the same as what it was. Without the driver circuit. But now the back EMF is gone. So I'm going to turn it down just enough so it'll pulse. And there we go. Just enough to give it to where it has dual back spikes. A back spike from the driver and one from the ringer. And it is charging the batteries again. And it's at 138 milliamps. I don't know if there's much difference in the light brightness. It's pretty hard to measure, but I'll turn it all the way up again. It's pretty much the same. Turn it down just enough to get the spikes again, and you'll see it charge. There you go. I figured that was a bit interesting and figured I'd like to share it. But thanks for watching, guys. Appreciate it. So always got something going on. Thanks for watching.